Okay, I hope I'm audible to all students who are attending this lecture of Advanced Econometrics. In this particular lecture, I intend to start with a new and a very important module within my lectures in Advanced Econometrics. This is regression analysis, with time series data. Regression analysis with time series data. This is one of the very important modules I cover up in my advanced econometrics course. Okay, the books I prefer to follow as reference for my lectures on this particular module. The main book I prefer to follow is Econometrics by Woolridge. Okay, and along with that, I also prefer to follow Econometrics by Gujarati and Porter. GNP, I'm just writing the short form Gujarati and Porter, GNP. These are the two main books I prefer to follow. I also follow some other books along with this, but the main books are Woolridge and Gujarati, which I prefer to follow for my lectures on time series data. Okay, so now in our module on time series, we are going to see how the regression evolves over time. So whatever data sets we have looked at so far before this module were all based on cross section. So all the data was at one particular point of time. All comparisons were made, all hypothesis testing, everything was done at one particular point of time. But now we are going to look at the data over a period of time. So let's first of all write a review. The first key aspect that distinguishes the time series data from the cross-sectional data is that there is clear temporal ordering. All the observations in the time series data are ordered with respect to time. Unlike the cross-sectional data which we have covered so far, where the data was listed at a particular point of time, in time series data, the data is listed over a period of time. So I can further elaborate that the temporal order indicates that the observations should not be arbitrarily ordered. The observations should not be arbitrarily ordered, as for many purposes we must know that the data for the time period t, immediately precedes the data for the time period t plus 1. So when we talk about temporal order students, the point to understand here is the observations are not arbitrarily ordered. So when I talk about the data for time period t, this data comes before the data for time period t plus 1. The whole paragraph is telling us the importance of temporal ordering. When I speak temporal ordering, it means the data is ordered with time. So period t minus 1 will come before period t will come before t plus 1, and so on. Okay, so also I can write that when analyzing the time series data, in social sciences, we also must recognize that the past can affect the future. The past can affect the future, but not vice versa. So when we talk about temporal ordering, observations in the past can definitely have an impact on the future, and they will in most of the cases, but the future cannot impact the past. Okay, so this is the first point within the review portion. Okay, I'm revising the first point again. We have started our lecture with time series data, but before digging deeper into the regression, we are first of all comparing time series with cross-sectional data. And one of the major difference between time series versus cross-sectional data is that in time series data, all the data is ordered temporally. That means the data is ordered with respect to time. In the cross-sectional data, we were listing the data at a point of time. In the time series data, the data for time period, let's say hypothetically period t, will precede or will come before the data for time period t plus 1. And when we look at the time series data in social sciences, we make the assumption that variables in the past can do have an impact on the future. That means past values of the variable can have an impact on the future, but values in the future can have no impact on the past. Let's look at the second key aspect. So I can write the second key aspect is that the time series data are almost always correlated. They are almost always correlated across time. They are always correlated across time, sometimes even strongly. Sometimes even strongly. So I hope students have understood this particular point. So what I'm trying to say is that, remember, we had done one of the properties, that there should not be any autocorrelation. In our lectures on simple linear regression model, one of the assumptions was that there is no autocorrelation. But in time series data, students will see that observations tend to be autocorrelated. Autocorrelation is pretty much normal in time series data as compared to cross-sectional data. In cross-sectional data, autocorrelation might be thought of as a disease, but in time series data, autocorrelation is normal. Observations tend to be correlated across time. They are going to exhibit dependence. For example, if I talk about the GDP of the economy this year, it will automatically depend on the GDP last year and last to last year and so on. So observations tend to be correlated across time. So I can say that this means that we can no longer rely on the assumption. We can no longer rely on the assumption of random sampling. This was one of the assumptions we had made in our multiple linear regression models. We can no longer rely on the assumption of random sampling commonly made in the time cross-sectional data. I can write commonly made in the cross-sectional data. In the cross-sectional data, we talk about random sampling. Okay, and we also make the assumption that there is no autocorrelation. But both these assumptions kind of get violated in the time series data. We can no longer assume random sampling, and we can no longer assume that there will not be any autocorrelation because observations will tend to be correlated across time. Okay, so I hope all students attending this lecture have understood points 1 and 2. Okay, if I erase all this off, let's now write some particular features of time series data. So I can write a note, some particular features of time series data. Some particular features of the time series data require special attention. Let me write those features. So feature number 1. First, when we collect the time series at monthly or quarterly frequencies, when we collect the time series at monthly or quarterly frequencies, the data can exhibit seasonality. The data can exhibit seasonality. So one important feature of the time series data is that it can exhibit seasonality. That, for example, when I'm looking at household expenditures, I might expect the household expenditures to go up during festivals. Let's say Christmas. Okay. On the other hand, how effective a fertilizer would be depends on the kind of crop I'm growing and which season that crop belongs to. Similarly, when I talk about ice cream sales, I would expect ice cream sales to be higher in summer months as compared to winter months. So when I talk about time series data and when I collect the data on a monthly or a quarterly basis, it can exhibit seasonality. Okay, so I can write the example. Examples of time series data with seasonality. Examples of time series data with seasonality include Christmas effect on expenditures, during Christmas month, during December, one would expect expenditures to be higher because Christmas leads to holidays and people tend to travel during holidays. They go for shopping, so the expenditures tend to go up. We would expect the expenditures to go up during this festival. Okay, effectiveness of fertilizer on production. Now it depends on which season and which crop we are growing. And ice cream sales is another example. We expect ice cream sales to be more in the summer months as compared to the winter months. Okay, the whole point is telling you that when you collect time series data, it can exhibit seasonality. It will show you a pattern. That pattern might be based on a particular season. The second point, many time series processes, many time series processes exhibit trends. Okay, so they might also show you the trend. What is the trend going for? Example of time series with trends include output per labor hour and nominal import. So we have done the concept of output per labor in our microeconomics course, and we talk about the production function. Nominal imports is something which we do in our macroeconomics course. So if you look at the data for output per labor or nominal imports, it might exhibit a trend. For example, in the last 5 years in our economy, imports have been going up because people are following a trend of adapting to foreign habits. Okay, so there's a trend because of which imports have gone up. So there are two important features of time series data which all students can see. Time series data can exhibit seasonality in behavior. Certain seasons you will see will have higher sales, certain seasons will have lower sales. And time series data can also exhibit trends. By collecting the data over a period of time, you will see that there's a certain trend being followed. Okay, so hoping students have understood both these points. Now, let's look at the terminology which we are going to use frequently when we talk about time series. Okay, so erasing all this off, terminology used in the time series context. Terminology used in the time series context. So let's look at, what kind of terminologies we will be using very often now. So I can write the observation on the time series variable y, the observation on the time series variable y made at the date t is denoted by yt. So yt denotes the value of the variable y at the date t. Now the date t can be a month, it can be a day, it can be an hour, it can be a year, etc. And I can further write the interval between observations. The interval between the observations, that is, I can write the period of time, between the observation t and the observation t plus 1 is some unit of time, such as it can be weeks, it can be months, it can be quarters, it can be years, etc. When I talk about the gap between t and t plus 1, the gap between these two time periods can represent weeks also, it can represent months also, quarters also, years also, days also, hours also, etc. Okay, so for example, I can write, for example, if the unit is years, if I measure time in years and t is equal to 2010, year 2010, then t plus 1 will be the year 2011, t plus 2 will be the year 2012, and so on. If I measure time in years, and suppose year t denotes the year 2010, then year t plus 1 will be the year 2011, year t plus 2 will be the year 2012, and so on. So I hope students have understood this. Now, I can further write special terminology and notation are used to indicate the future and past values of y. Okay? Special terminology and notations are used to indicate the future and the past values of y. So I can write the value of y in the previous period is called its first lagged value. Is called its first lagged value or its first lag, and is denoted by yt minus 1. So if yt denotes the value of the variable y at date t, then yt minus 1 is its first lagged value. That means it's a value of taken by variable y with a 1 period lag. 1 period lag means from t I go 1 period back, t minus 1. Okay. Similarly, yt minus 2 denotes the second lagged value of y. And I can write yt minus j denotes the jth lagged value. The jth lagged value, or I can write for simplicity jth lag of the variable y. Okay, so I'm repeating the whole thing again. In this particular slide, we are looking at how to use terminology involving time series data. Suppose the variable of attention is variable y. We are talking about variable y, which has a temporal ordering. That means the variable y evolves over time. Yt denotes the value taken by variable y at the time period t. Okay. Yt minus 1 is the value taken by variable y with a 1 period lag. That means yt minus 1 period before. Yt minus 2 is the value taken by variable y with a 2 period lag or a second lagged value. Yt minus j in general is the value taken by variable y with a jth period lag or jth lagged value. And the difference from period t to t plus 1 can be measured either in hours, days, weeks, months, quarters, and so on, years, and so on. Similarly, if I talk about, we have been talking about the lag values. If I talk about future values, if I erase the initial part off, erasing this part off, I can write similarly. Yt plus 1 denotes the value of y one period in the future. One period into the future. Yt plus 2 denotes the value of y 2 periods into the future, and so on. So I hope students have understood this. So I can say that yt denotes the value of y in period t. Yt minus 1 is the first lagged value. Yt minus 2 is the second lagged value. Yt minus 3 is the third lagged value. So I can write this. First lagged value. Second lagged value. Third lagged value. And I can keep going back into the past. Or yt plus 1 is one period in the future. Yt plus 2 is 2 periods in the future. Yt plus 3 is 3 periods in the future, and so on. I can go into the future. This is the value of y in the period t. Assuming today we are in period t. Okay, so let's take an example and then we can wind up the lecture today. Let's look at a numerical example. Let's look at this numerical example. Consider the data on unemployment. Consider the data on unemployment for the period 1992 to 2001 as follows. Let me make a table. We have year and we have the variable unemployed. We have year and we have the variable unemployment given by UNEM or just unem. We are given 1992, 93, 1994, 1995, 1996, 1997, 1998, 1999, 2000, 2001. Suppose I've taken the data exactly from Woolridge. It's not my data. I've picked up from the book Woolridge. So 6.3 here, 6.2, 6.0, 5.9, 5.8, 6.1. Okay, the data is being taken from the book Woolridge. First question asks us, what are the values of unemployment variable for T taking the values 1992, 1993 and 1999? Very simple. I need to find out what is the value taken by the unemployment in period T, where T takes the values 92, 93 and 99. So unemployment in the year 1992 is how much? 6.9. Unemployment in the year 1993 is 7.2%. Data is in percentage term. And unemployment in the year 1999 is 5.9%. Question 2 asks us, what are the values of unemployment in T minus 1 for T taking values 1992, 1993, 1999. So now it's T minus 1. So when T takes 1992, 1992 minus 1 is 1991. The data is not available. You can see from the table, there is no data for year 1991. The data starts from the year 1992 and it's unemployment T minus 1. When I put T as 1992, 1992 minus 1 is 1991, but there is no data for 1991. When I put T as 93, 1993 minus 1 is 1992, and for 1992 the unemployment rate was 6.9%. The unemployment rate in 1999, so when I put T as 1999 minus 1, it is 1998, and unemployment in 1998 was 6%. So I hope students have understood this. So I stop now in this particular lecture. The objective of this lecture was to introduce all students to the one of the very important modules in our econometrics course called regression analysis with time series data. We have talked about how time series data differs from the cross-sectional data. We have also talked about the terminology we are going to use the time series data. And we have also talked about some particular features of time series data like seasonality and trends. Okay. In the next lecture, we are going to start our discussion with examples of time series regression models. We are going to talk about time series regression models in the next lecture. So I stop in this lecture. I hope students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.